Chapter 13. Understanding Datasheets. Intro. A datasheet, or spec sheet is a document that summarizes the performance and other characteristics of a product, machine, component, e.g., an electronic component, material, a subsystem, e.g., a power supply, or software in sufficient detail that allows a buyer to understand what the product and a design engineer to understand the role of the component in the overall system. What is datasheets? Typically, a datasheet is created by the manufacturer and begins with an introductory page describing the rest of the document, followed by listings of specific characteristics, with further information on the connectivity of the devices. In cases where there is relevant source code to include, it is usually attached near the end of the document or separated into another file. Datasheets are created, stored, and distributed via product information management or product data management systems. Depending on the specific purpose, a datasheet may offer an average value, a typical range, engineering tolerances, or a nominal value. The type and source of data are usually stated on the datasheet. A datasheet is usually used for the commercial or technical communication to describe the characteristics of an item or product. It can be published by the manufacturer to help people choose products or to help use the products. By contrast, a technical specification is an explicit set of requirements to be satisfied by a material, product, or service. The ideal datasheet specifies characteristics in a formal structure, according to a strict taxonomy, that allows the information to be processed by a machine. Such machine-readable descriptions can facilitate information retrieval, display, design, testing, interfacing, verification, system discovery, and e-commerce. A product datasheet, PDS, like any datasheet, has a different data model per category. It typically contains identifiers like manufacturer and manufacturer product code, GTIN. Classification data, such as UNSPSC. Descriptions such as marketing texts. Specifications. Product images, feature logos. Reasons to buy. Leaflets, typically as PDFs. Manuals, typically in PDF. Product videos, 3D objects, and other rich media assets. In OpenIceCat, the global open catalog or open content project in which hundreds of manufacturers and thousands of e-commerce sellers participate, the data models of tens of thousands of taxonomy classes are defined, and millions of free PDSs can be found conforming these datasheet data models. Datasheets for automobiles may be described under several names such as features, specs, engineering data, technical summary, etc. They help communicate the technical information about a car to potential buyers and are useful for comparisons with similar cars. They might include critical inside and outside dimensions, weight, fuel efficiency, engine and drivetrain, towing capability, safety features and options, warranty, etc. Node MCU datasheet. Node MCU. The ESP8266 is the name of a microcontroller designed by Espressif Systems. The ESP8266 itself is a self-contained Wi-Fi networking solution offering as a bridge from existing microcontroller to Wi-Fi and is also capable of running self-contained applications. This module comes with a built-in USB connector and a rich assortment of pinouts. With a micro USB cable, you can connect Node MCU DevKit to your laptop and flash it without any trouble, just like Arduino. It is also immediately breadboard friendly. Specification. Voltage, 3.3 voltage. Current consumption, 10 microampere to 170 microampere. Processor, Tensilica L106 32-bit. Processor speed, 80 to 160 MHz. RAM, 32 KB to 80 KB. Flash memory attachable, max 16 MB, 512 KB normal. Wi-Fi Direct, P2P, SoftAP, 802.11 support, BGN. Plus 19.5 dB milli output power in 802.11b mode. Integrated TCP/IP protocol stack. GPIOs, 17, multiplexed with other functions. Analog to digital, 1 input with 1024-step resolution. Maximum concurrent TCP connections, 5. Using Arduino IDE. The most basic way to use the ESP8266 module is to use serial commands, as the chip is basically a Wi-Fi/serial transceiver. However, this is not convenient. What we recommend is using the very cool Arduino ESP8266 project, which is a modified version of the Arduino IDE that you need to install on your computer. This makes it very convenient to use the ESP8266 chip, as we will be using the well-known Arduino IDE. Following the below step to install ESP8266 library to work in Arduino IDE environment. Install the Arduino IDE 1.6.4 or greater. Download Arduino IDE from arduino.cc, 1.6.4 or greater, don't use 1.6.2 or lower version. You can use your existing IDE if you have already installed it. You can also try downloading the ready-to-go package from the ESP8266 Arduino project. If the proxy is giving you problems, install the ESP8266 board package. Enter http://arduino.esp8266.com/stable package_esp8266com_index JSON into additional board manager URLs field in the Arduino v1.6.4 plus preferences. Next, use the board manager to install the ESP8266 package. Scroll down to ESP8266 by ESP8266 Community and click Install button to install the ESP8266 library package. Once installation completed, close and reopen Arduino IDE for ESP8266 library to take effect. Set up ESP8266 support. When you've restarted Arduino IDE, select Generic ESP8266 module from the Tools to Board drop-down menu. Select 80 MHz as the CPU frequency. You can try 160 MHz overclock later. Select 115,200 baud upload speed is a good place to start. Later on you can try higher speeds, but 115,200 is a good safe place to start. Go to your Windows Device Manager to find out which COM port USB serial CH340 is assigned to. Select the matching COM/serial port for your CH340 USB serial interface. Note: if this is your first time using CH340 USB to serial interface, please install the driver first before proceed the above COM port setting. The CH340 driver can be downloaded from the below site. https://github.com/nodemcu/nodemcu-devkt/tree/master/drivers. Blink test. We'll begin with the simple blink test. Enter this into the sketch window, and save since you'll have to. Connect a LED, as shown in Figure 3-1. Now you'll need to put the board into bootload mode. You'll have to do this before each upload. There is no timeout for bootload mode, so you don't have to rush. Hold down the flash button. While holding down flash, press the reset button. Release reset, then release flash. When you release the reset button, the blue indication will blink once. This means it's ready to bootload. Once the ESP board is in bootload mode, upload the sketch via the IDE, Figure 3-2. The sketch will start immediately. You'll see the LED blinking. Hooray!